Hello, fifth graders. Welcome back. Happy Monday. I hope you had a great weekend. I miss you all, and I hope you're doing well and okay at home. So this week we're going to continue talking about equivalent fractions, part one. So you had the introduction last week, and this week we're just going to continue working on our word problems and really getting it all down. Okay. So just a review of what equivalent fractions are. They're when fractions have different numerators and denominators, but they represent the same value of the whole. So last week we were looking at pizzas when we looked at the definition, and I just wanted to show you a little different representation. These are just bars. So we have 1/2, 2/4, and 4/8. As you can see, all of the pictures are a little different, but the orange shaded part is the same, and that represents the value. And how they got it is we talked about you can multiply and use a factor to find equivalent fractions, or you can divide and use a divisor to find equivalent fractions. So from this, it looks like they multiplied because they started with 1/2 and got bigger. Whenever you multiply, your numbers get larger, your value size gets smaller. Whenever you divide, your numbers get smaller. Okay. So we are still practicing our strategy RDW, so we're going to read this problem. We're going to circle the important information and find what is the question asking us, okay? So Farmer Shannon planted flowers in 1/3 of her garden. Use the area model below to represent the fraction of flowers she planted in her garden. So 1/3 of her garden, important. And it's asking us to use the area model below to represent the fraction of the flowers she planted in her garden, okay? So I know what 1/3 looks like, okay? So this is 1/3. I'm going to draw a quick picture. So I know that's 1/3. So if I'm looking at this picture right here, and it tells me to use the area model to represent the fraction 1/3. But obviously this picture does not look like this picture. So I'm going to color an amount that will be the same value, even though it doesn't look the same. So if I look here, it shows that this piece is colored. So it looks like if I colored these two pieces, then it's the same amount shaded, okay? But is this fraction the same as this fraction? No, because the pictures are different, but the values are the same. So we need to figure out what this picture represents. Well, it looks as if I have 1, 2, 3, 4, 5, 6 squares, so that would be my denominator, and 2 are shaded in, so that's my numerator. So if we go to the next slide, it says write an equivalent fraction to 1/3, and it says hint, use the picture you just created. So if we use the picture, we said there were 6 squares are together, so that's the denominator and that's the whole, and the part that we colored in was 2. So let's think about how we got to 2/6. If we were using a factor divisor, how would we go from 1/3 to 2/6? So before I mentioned that if the numbers are bigger, then we use a factor and we multiply it. Again, the numbers are bigger, but the parts and the value is smaller. So we know we're multiplying, and I have to think to myself, what 1 times what equals 2? Well, I know 1 times 2 equals 2, and then whatever I do to the top, you have to do to the bottom. So 3 times 2, does that equal 6? It does. So we know that 1/3 is equivalent to 2/6, okay? All right, let's read this one. DeAndre planted flowers in 2/3 of his garden. Sandy planted peppers in 3/6 of her garden. Did they plant an equal amount in their gardens? Explain using pictures. So first we're going to circle that 2/3 is important and 3/6 is important. and we're trying to figure out if they planted an equal amount in their gardens, okay? So let's go to this first one, and I already created the hole with the 3, and so I need to shade in the part, and that's 2/3. And to really like compare the numbers, we need to make sure the bars are the same size, which they are. So then Sandy planted peppers in 3/6. So again, I already created the hole, and I need to color in 3 parts. Okay, and if we look at these, are these an equal amount? No, they're not, because it's colored into this area, but then it stops right here. So there's a little bit more that they could color in to make it equal. So no, these are not equal, which means 3/6 and 2/3 are not equivalent fractions. So we're going to now find equivalent fractions for 2/3 and 3/6. Okay, so I'm going to look at this, and I'm going to use the factor 2. So I'm going to say times 2. 2 times 2 is 4. 3 times 2 is 6. So before we have 2/3, and now we're going to color in 3/6 and see if it's the same. Okay, so here's our 4/6, and let's color it in. 1, 2, 3, 4. Is it the same? Sure is. Those are equivalent fractions. Now let's do 3/6. So this time, right on this side, we use the factor 2. On this side, I think I'm going to use the divisor 3, because I know 3 will go into 6, and 3, of course, will go into 3. So we're going to divide by 3, divide by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So if we create we're going to create a chart and see if it works here, okay? So give me just a second while I create it. So again, we're gonna have to make sure that size is a little smaller so that they're the same. Okay, so let's see if we can have the same. So we're gonna color in 3/6, 1, 2, 3, and then we're gonna color in 1/2. Is that the same? It sure is. So we have an equivalent fraction. So now in your exit ticket, you're going to answer the 2 questions on Canvas. And if you need any help, just let me know. And I will see you the rest of the week. Have a great day.